Good morning, good afternoon, or good evening. Welcome to A Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2025, paper 1, very 1. As always, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. And if you have any questions, please leave your questions in comments and I will try to answer as soon as possible. And if you're looking for extra resources, you can also join Patreon. On Patreon, you will see past paper solutions, PDF, topic-wise questions, revision guides, and other resources. Question 1 says, which quantity is a vector? So vector quantity has magnitude and direction. Now, if you look at given quantities, pressure is a scalar. To describe pressure, we don't need to talk about direction, so it's a scalar quantity. To describe temperature, we also no need to talk about direction. Means we don't need direction to describe temperature. So this is also scalar quantity. Weight is a force due to gravity. So it's a vector quantity. So when we talk about force, we say force can be to the left, force can be to the right, force can be down. So weight is a vector quantity. Work is a scalar. It's not a vector. So the answer for this question has to be 6. Second question says 4 students A, B, C, and D have completed an experiment to determine the acceleration of free fall G. Each student repeated the experiment 3 times. The determined values of G are shown in the table. Which set of results has a high precision and a low accuracy? So first of all, we need to understand what exactly is precision. Precision simply tells us how close the readings or measurements are to each other. So it means that it depends on the range. So if the range is narrow, it means high precision. So range, if it is narrow, it means high precision. If it is not narrow, if it is wide, it means low precision. So this tells us high precision. So we can write down here. So this will tell us high precision. If the range is wider, it means low precision. So we can write on here low precision. Now for this question, high precision, we have to find out which data set has high precision. So it means the range should be narrow. The narrowest range has the highest precision. Now the second thing we need to understand is about accuracy. Accuracy. What exactly is accuracy? It's linked with the mean value. How close the mean value is to the true value. So if the mean value is close to true value, it means high accuracy. We can say high accuracy. And if far means big difference between mean value and true value, that means low accuracy. Low accuracy. So for this one, we need to find low accuracy set of data. So it means difference between true value and mean value should be the largest. So simply you can find the mean value for each one. You can also find out the range of each data set and then you can compare. To keep it simple, not to spend a lot of time on this question, I will simply look at this data. For example, D, you can look at all data you can calculate. So for D, for example, I will be looking at this one. So what is the mean value of this? Mean value. So the mean value we can simply determine. So let's say the mean value that will be equal to 10.1 plus 10.2 plus 10.1 and this is divided by 0. So we can find out the mean value. So we have here 10.1 plus we have 10.2 and plus we have 10.1 again. So divided by, this has to be divided by 3 so we can find out the mean value. So the mean value in this case is 10.1 up to 1 dB. So mean value is 10.1. We can also find out the range of this now. The range of this one is the maximum value, that is 10.2 minus 10. So the range will be equal to 0.1. We can also find the difference now, difference between mean value and actual value. We have mean value 10.1, actual value is 9.81. So if we solve this one, we will get 0.9. And low accuracy, it means this difference should be the largest. So you can calculate for all of them, you will see this difference is the largest. And this range has to be the smallest one, means the narrowest one, because data must have high precision. So answer for this question has to be D. So this will be the answer. You can do calculation for rest of the data by yourself. Third question says the diameter of a ball is measured as 5.26 plus minus 0.02 centimeters. What is the absolute uncertainty in the volume of the ball? So first of all, we can start with volume of the ball. Volume is equal to 4 by 3 pi r cube. The fractional uncertainty in the volume means delta v by v has to be equal to 3 times the power of r delta r by r. And as these two are constants, when quantities are multiplied and divided and we are calculating the uncertainties, we can simply ignore because this is just a factor, so it will be divided and multiplied by this one, so overall result will be the same. So simply we can ignore fast simplicity. So we need to calculate for this one delta v. So delta v will be equal to 3 times delta r by r. Now simply we need to find the values. We need to find what is value of v, what is value of delta, what is value of r, then we can plug in and find the answer. So first of all, let's try to find out what is r. R is half of diameter, so this is 5.6 divided by 2. So if we solve this one, we will get 2.63 centimeters. So this is value of r. And volume we can now find out. Volume will be equal to 4 by 3 pi r cube. So we can plug in value. 4 by 3 pi times 2.63, and we can take cube of this one. We can find out value of volume. So here we will get value of the volume. We can also do actually without volume, so I will go to that point very soon. And we need to find out delta r. Delta r has to be equal delta d by 2. Delta d by 2 means here we have delta e. So this is delta d, that is equal to 0.42 divided by 2. So we will get 0.01 centimeter. So here we can write down 3 and volume is 4 by 3 pi r cube. We no need to calculate this one. So here we can say this is delta r by r. From here, this r square, r cube, we can cancel with this one. So here is r square. Now we can rewrite this one. And this 3 we can cancel with this one. So we have 4 pi r square times delta r. So simply we need to plug in the values now. So we have 4 pi and r in this case is equal to 0.63 square multiplied by delta, that is equal to 0.01 centimeters. Now if we solve this one, we will get 0.87 centimeter cube. So this is delta v. So the answer for this one has to be B. So there are few points you need to understand. One is the difficult point, how to calculate absolute uncertainty of radius when absolute uncertainty of diameter is given to us. So simply you need to divide by 2. Then this part you need to understand how to find the fractional uncertainty in the volume. So if you understand about these points, then rest is just simple mathematics. Question 4 says two vectors x and y are shown. What are the directions of x plus y and x minus y? So this is simply about vector addition. Now first of all, we can take this vector. So I can draw here. This is our vector x. I can also draw vector y using a different color. Let me try this one using a different color. So we have vector y. So this is our vector y. I'm trying to make it as accurate as possible. Now first of all, we have to find out x plus y. So it simply means that we have to add these two vectors together. So I will take this vector y. I will simply move this one. I will place this one here. So this is our x plus y. So what is our resultant vector? For resultant vector, let me use red. From tail of first to the head of last. So this is our x plus y. So we can say x plus y. So the answer is A. Our answer is B. Now let's move on to the second part. We need to find out. So this is our x plus y. So we can draw this arrow here. Now for the second part, we need to find out x. We can say plus minus y. Negative factor. Negative. So for this purpose, we can take over vector. We can take this vector y. So let me move this one to here. And vector y has to be the negative vector. This has to be the negative vector. So the negative vector means we can just rotate this one by 180 degrees. So this is negative. Now we can move this one and we can place this one here. So this is minus y. So in this case, the resultant vector, you can see the resultant vector is from the tail of first to the head of the last vector. So this is how we can add them together. So here this one is x and this is minus y. So this is x minus y. So the resultant vector is this one. Now if you look at the given options, answer should be B. Question 5 says a ball is projected vertically downwards with an initial velocity of 20 meters per second. A resistance is negligible. What is the displacement from its initial position of the ball after a time of 1.5 seconds? So simply we can imagine this is our ball. It is thrown downward with initial velocity of 20 meters per second. And we need to find out what is the displacement when the ball is here and the time passed between these two positions. Delta t is equal to 1.5 seconds. So we need to find out the displacement from this point. So we can simply take downward as positive. So our answer will be positive. Now for this one, what we have value of u that is given to us, value of t is given, and also we have value of acceleration due to gravity. So we can simply use s is equal to ut plus 1 half at square. Now in this case, we have taken down is positive. It means this one is positive, and acceleration is also down, which means g this is equal to 9.1 meters per second per second. This one down, this is also down. So this value also will be taken as positive because we have taken down is positive. You can also take up positive, so these two values will be negative. So s in this case will be equal to 20 times 1.5 plus we have 1 by 2, so 9.81 times 1.5 squared. So if we solve this one, we will get 41.0 meters. So up to 2sf, this is 41 meters. That's all for today's lesson, and I'll try to upload remaining questions before your final exam on 11th of November. If you have any questions, you can leave your questions in comments and I will try to answer as soon as possible. And I have also uploaded a lot of paper 1 questions on the channel. So you can go through those papers and those solutions. If you're not clear about any point, need clarification, you need more detail or explanation, you can leave your questions. See you in next video. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2025, Paper 1, Variant 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together. Let's improve together. Question 6 says, a survey's device emits a pulse of light. The light is reflected from a wall 150 meters away. What is the total time taken for the pulse to travel from the device to the wall and then back the device? So simply, first of all, we can imagine this one is device. It is emitting light and the wall is located somewhere here. So the light waves, they will travel from the device to the wall. So we can say this distance is t. And then they will travel back. So this distance also has to be t. So what is the total distance? Total distance is equal to 2. So 2d. And the speed, this is light. So the speed has to be equal to 3.0 times 10^8. So simply we can say the total distance traveled 2d. This has to be equal to v times total time taken. So this is t total. We need to find out what is value of t total, the total time. So this will be equal to 2d divided by the speed of light. So we have 2 times 150 meters and this is divided by 3.0 times 10 to 8 meters per second. So if we solve, we will get 1.0 times 10 to 6 seconds. So this is equal to 1 microsecond. Very important one. What this one is better. This means micro. So it means 1.0 microsecond. So the answer for this one has to be D. Question 7 says, which equation of uniformly accelerated motion can be derived using only the gradient of a velocity time graph? So first of all, simply we can sketch velocity time graph. So this is velocity on y-axis and here we have time on x-axis. So we can also draw this line. So let's say the initial velocity is u and the final velocity we can say this is v. So what this gradient is representing? So the gradient will be equal to delta v by delta v. So we can simply say this is delta V by delta t. So in this case, the final velocity is V, initial velocity is U, and we can say this t is equal to 0. So we can say this time is t, and here t is equal to 0. So simply this means t minus 0, V minus U, and this is divided by t, and delta V by delta t, this is equal to A. So we can say V minus U, this is equal to AT. So V is equal to U plus A. So this is the first equation. I mean, this equation can be derived only using gradient of velocity time graph. So the answer for this one has C. Question 8 says an object is projected horizontally from a table at time t is equal to 0. The object falls in a uniform gravitational field. A resistance is negative. Graphs P, Q, R, and S are velocity time graphs. Which graph represent the horizontal and vertical components of the velocity of the object? I mean, which two graphs they represent horizontal and vertical components of velocity? So first of all, we need to understand in this case, ball is projected horizontal. So it will go somewhat like this. So there is no acceleration along horizontal. So we can say acceleration along horizontal. This is equal to. So it means that Vx has to be constant. So it has initial horizontal velocity. This is u. So it has to constant. So simply we can say Vx has to be equal to constant, and this has to be equal to u. And along vertical, it has acceleration along vertical, and this acceleration is equal to, and this is constant. So we now say acceleration along vertical, this is equal to d, and this is constant. As acceleration is constant, it means that the gradient of velocity time graph has to be constant. Gradient has to be constant, and initial velocity, very important one, is also equal to 0. So we will say gradient has to be constant, has to be also constant, because gradient will be equal to x. Now if you look at the given options, so this is initial velocity is 0, so it fulfills this requirement. Gradient constant, it fulfills the second requirement as well. So this is representing the vertical of velocity. It is increasing vertical, and this is remains constant with time. So this has to be horizontal. So this is how we can answer. So horizontal has to be q. So answer is A or B. Vertical has to be P. So the answer is A. Question 9 says, what is always conserved in elastic fields? In elastic fields, we need to understand kinetic energy is conserved and momentum is also conserved. Momentum is conserved as long as there is no net external force acting on the system. So for any isolated system, momentum is conserved. But kinetic energy is conserved only if clearance is elastic. Now, if you look at the given options, total kinetic energy is conserved. Yes, this is true. Velocity, no. Velocity is not conserved. So this is not answer. Total kinetic energy is conserved. Yes, this is true. Total velocity is not conserved. This is also true. So the answer for this question has to be B. Question 10 says a firework travels vertically upwards in air. Gases are pushed vertically downward from the firework. Several forces that act on the firework and gases are shown in the figure. Which forces are Newton's third law of wave? To answer this question, first of all, we need to understand what is Newton's third law of wave. So Newton's third law of wave, there are certain conditions need to be fulfilled. Newton's third law of wave. So we can simply try to understand first of all what is Newton's third law of wave. First thing, forces must have equal magnitudes. So equal magnitude, equal. And second, opposite directions. Two forces which will form a Newton third law of wave, they must have equal magnitude and opposite directions, or you can say opposite in directions, and they must act on different objects. Act on different objects. So this is act on different objects. And the most important, they must be of same type. Same type. For example, pushing force. Both of them have to be the pushing forces. They have to be gravitational forces, and so on. Now, if you get given options, air resistance and force on gas. Air resistance, different type of force. Force on gases, different type of force. So it is not possible. Air resistance and thrust. These are also acting on the same object. I mean, air resistance is acting on rocket. Thrust is also acting on rocket. So they're acting on the same object. This is also not possible. Force on gases and thrust. Yes. Force on gases. This is the pushing force by rocket. Pushing force by rocket on gases. You can say on gases. And upthrust is the pushing force by gases. by gases on rocket. So these are two same type of forces. They have equal magnitude. They are in opposite direction. So the answer for this question should be C. Thrust and weight, no, they are different type of forces. This is the pushing force, so they're not same type of forces. So this is pushing force, and this is the gravitation force. Gravitation. So they are not same type of force. Gravitation. No. So this is also not possible answer. So the answer for this question is C. Question 11 says two blocks K and L slide towards each other along a horizontal frictionless surface. The diagram shows the momentum of the two blocks just before they collide. During the collision, the blocks are in contact with each other for a time of 0.084 seconds. After the collision, the blocks separate and block L moves back along its initial path with a momentum of 0.12 kgs meter per second. What is the magnitude of the average force exerted on block L by block A during the collision? Very nice question, conceptual question. You have to be here. Let me explain you first of all. When two bodies collide with each other, so here we have A, and here we can draw this is L, this is log L. So when two bodies collide with each other, they exert the same force on it. Very important one, they exert the same force on each other, and they exert force in opposite directions on each other. Opposite directions. And also you need to understand time of contact, or we can say time of impact also is the same. Opposite directions, time of contact, same. Very important ones. Time of contact, same force means the magnitude of the force is the same. So if magnitude of the force is the same and time of contact is same, so it means impulse is the same. So we can say as impulse is equal to force times delta t. So impulse is also the same because force is same, time of contact is also the same. So it also tells us that change in momentum is also the same. So the change in momentum of block L and change in momentum of block K is the same. And also the force is the same, time of contact is the same. This time they're asking you to calculate the force exerted on block L by block K. So the force on block L, block L, that will be equal to the change in momentum of the block divided by time. But this force is also the same for block K, block L as well. On block L by block A. So the force on block A also is the same. So they can give you this data and they can ask you what is the force exerted on block A. But the momentum of block A after collision is not given. So you can also calculate from this given data. So you can calculate force on block L, and that force has the same magnitude as the force on block A. This can be a tricky question next time. Now let me explain you how you can answer. Delta P. So in this case, its momentum is to the left. We can take to the right is positive. This is to the right. So for this question, it is given to us after collision, it moves back. So we can say what is happening to block L after collision. This block go this way, and the momentum of this one is given to us 0.12 kg meter per second. So we will be taking to the right positive, to the right. So if we take to the right positive, so the final momentum we can say E final minus P initial over delta T. T final is 0.12 minus P initial is this one. So this is minus 0.46. Momentum is a vector quantity divided by the time of contact. This is given 0.084. Now if we solve this one, we will get force is equal to 6.9 newtons. So this is the force on L. So this is how you can calculate. These points are very important one. That's the reason I have mentioned these points. So these 4 points, you have to be clear. When two bodies, they collide with each other, what is the same? Force is the same. Time of impact is the same. Impulse is the same. Change in momentum is also the same. So the answer for this question is C. For question 12, we need to figure out what is the useful output power that must be provided by the pilot to move vertically upwards at a constant speed of 2.5 meters per second. The machine and the pilot mass is given to us. So this is the total mass. And it is also given to us to move this one at constant speed. So it simply means that move at a constant speed, the applied force in upward direction, this has to be equal to mv. So simply we can calculate P, this has to be equal to Fv, and F has to be equal to mg times V. Now simply we can plug in value. M is equal to 120 and G is 9.81 and V is equal to 2.5 meters per second. that. So if we multiply this one, we will get 2900 watts up to 2s. So the answer for this question has to be A. And this is the useful heat. Of course, there is some energy loss due to friction. We are talking about useful heat out, mean how much force has to be in the output. And that force has to be equal to mg because it is moving at constant speed. Question 13 says, which row describes a pair of forces that forms a couple? When two forces that form a couple, they must have same magnitude, opposite directions, and also they should not be acting along the same line. So these are the points we need to understand. Direction of the forces has to be opposite. So answer can be A, or answer can be B. Magnitude of the forces should be the same, not different. So answer for this question has to be B. So when two forces they form a couple, there must be perpendicular distance between them. Let's say this force is acting up, so the force here it should be acting down. They must have the same magnitude because they have to cause only rotation and they should not be along the same line. So the answer is C. Question 14 says a uniform cylinder of weight 25.0 newtons is suspended from a Newton. The cylinder is fully submerged in water as shown in the figure. The reading on the Newton meter is 10.0 Newton. The water is replaced by a liquid with a density 10% greater than the density of water. Cylinder remains fully submerged. What is the new reading on the Newton meter? So first of all, we need to understand the force is acting on the cylinder. The weight of the cylinder that is acting down. There is upthrust that is acting up, and also there is tension in the string that is equal to the Newton meter reading. We can say that's T. So in this case, as this is at rest, so it means W has to be equal to U plus T. We need to find out value of U first of all. W is 25.0 minus T is 10.0. So the value of upthrust, we can say initial value of upthrust, this is 15.0 newtons. And new value of density is 10% greater than the previous one. So it simply means that 1.1 of previous density. Now how much upthrust will change? So it simply means that the new value of upthrust, because upthrust is equal to rho GV. As upthrust in this case, upthrust is directly proportional to rho means density. So if the density increased by 10%, upthrust also has to increase by the same amount because these two quantities are directly proportional. So it means this is 1.1 of the previous value, that is 15.0. This value, previous value for upthrust. Now if you multiply, we will get this is 16.5 Newton. So what is new reading? So we need to find out T. So we can rearrange this equation and we can say T from here will be equal to W minus U, the new value of upthrust. So this is new value of tension. So W we have that is equal to 25.0 newtons. New value of upthrust is 16.5. So if we solve, we have 8.5. So this is new reading on Newton meter. So the answer for this question should be A. Question 15 says a student balances a 30 centimeters ruler on a fulcrum set at the 15 centimeters mark. She then places the 50 grams mass on the 23 centimeters mark and the 20 grams mass on the 11 centimeters mark as shown in the figure. Which mass should she place on the 7 centimeters mark to restore the balance? So this is basic question about equilibrium. So due to this weight, moment will be clockwise. Due to this one will be counterclockwise. Due to this one will be counterclockwise. And this is 15 centimeters mark. We can say this is 15. So the sum of clockwise moments has to be equal to sum of counterclockwise moments about the pivot. So we can say about the fulcrum, or fulcrum is about the pivot. So moment due to this one 50 grams. So this is 50 gram mass. I will not multiply with G because G will be cancelled on both sides. And the distance from pivot is 8 centimeters. So this is 8 centimeters. And due to 20 grams, this will be 20G multiplied by 5 centimeters, 5.0 centimeters. So this will be 4 because this is 11. So this one has to be 4. So this is 4.0 centimeters plus due to this one. We don't know the mass. We can simply say that is M times. So the distance will be 8 because this is 7, this is 15. So this is 8.0 centimeters. Now in this case, you can also see here centimeters on both sides. This will be cancelled. And now if we solve for the mass, our answer will be in grams. So this will be equal to 40 grams. So the answer for this question should be B. So this is how you can, you don't need to multiply with G because it will be cancelled. You also no need to convert these units into kilograms because the final answer you need is in grams. Good morning, good afternoon, or good evening. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May-June 2025, Paper 1, Variant 1. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 16 says, a submarine is at a depth of 130 meters below the surface of the sea. The pressure on the submarine due to the seawater is P. The submarine sinks to a depth of 260 meters below the surface. Assume that density of seawater is constant. What is the difference between the pressure on the submarine due to the seawater at the two depths? So this question can be answered very quickly. So if you look at these two values, 130 meters and 260 meters. So 260 meters is simply 2 times of 130 meters. So we need to find out the difference in P. So delta P we need to understand. This is equal to rho G delta H. So if delta H is double, so we can also say here delta P, this is directly proportional to delta H. If delta H is double, delta P has to be double. So if we say the pressure at this height, this depth is P, so at 260, the P has to be equal to 2P. So what is the difference between these two? So the difference we can simply say delta P will be equal to 2P minus P, so the answer is P. So the answer for this question has to be C. So this is how quickly you can answer the question. Now let me explain you this one step by step, little bit in detail, so you will be able to answer this one in a nicer way to develop your concept. Now first of all, we can say at 130 meters, what is the value of the pressure? So P is equal to rho G times 130 meters. This is the H. And then we can say at 260 meters, we can say this is P mu. This will be equal to rho G times 260. We can also write down this one. This is 2 times rho times G times 130. Now you can see here, this is the P, this one is P. So the P mu, we can say this is equal to 2P. So what is delta P? So again delta P, we can say this is equal to P mu minus P. So this is 2P minus P. So the answer is P. So this is systematically you can answer. But the smart way to answer this question is, as I explained before. So as depth is double, this is double, so P has to be double, so the difference has to be 2P minus P. So that's the reason answer for this question is C. Question 17 says an object is falling in a uniform gravitational field. Which two quantities are sufficient to calculate the change in gravitational potential energy? So first of all, we need to understand change in GPE, gravitational potential energy. This is equal to mg delta H. But mg is equal to the weight of the object, means the force of gravity on the object. So we can simply say this is W times delta H. So W is the weight. So W is the weight, the force of gravity on the object, and delta H, this is the vertical displacement, the change in height. So this is vertical displacement. Now if you look at given options, option A is mass and acceleration of free fall. This is not enough. Mass and change in vertical displacement. This is also not enough. So this is also not possible answer. Weight and acceleration of free fall. So this is incorrect. If we have weight, we need vertical displacement. So this option is also not correct. Weight and change in vertical displacement. Answer for this one has to be D. So this is delta, so we can also say this is change in vertical displacement because we're calculating change in GP. So this is change in vertical displacement. So the answer for this one is D. Question 18 says the points X, Y, and Z are on a rough horizontal surface. A box P is pushed across the surface from X to Y and then from Y to Z. The distance from X to Y is 3 meters. The work done against the frictional force in moving the box from X to Y is 150 joules. So we can say the work done here, we can say W1, this is equal to 150 joules. The work done against the frictional force in moving the box from Y to Z is 200 joules. So we can say work W2, this is equal to 200 joules. An identical box Q is pushed in a straight line from X to Z, along this line. The magnitude of the frictional force between the boxes and the surfaces is constant. How much extra work is done against the frictional force in moving P then Q? So for this question, we need to understand is that we move one box along this path, along this one. So this is box P, and the box Q is moved along this line, but frictional force is the same. Frictional force is the same. So as here we have distance and we also have the work done, so we can find out the frictional force. So we can say W1, this has to be equal to F times T. So we can find out value of the frictional force. So we have 150, this is divided by 3 meters, so the frictional force is 50 newtons. Now from W2, we can find out value of distance. W2 is equal to F times d between y and z, yz. So dyz we can find out. So dyz, this will be equal to 200 divided by 50. So we will get 4 meters. And so this side is 4 meters. This side is 3 meters. So this side has to be 5 meters. Simply you can calculate. Let's say this is xc. So we can calculate xc. That will be equal to 3 square plus 4 square, just right angle triangle. So if we solve this one, this is 9, and here we have 16. So xc is equal to 5 meters. So xc is 5 meters. So this is 5 meters. So now we can find out work done from x to z. We can say wxc. This is equal to f times dxc. dxc. So we can also say this is dxc. So to be consistent, you can say dxc. So this is also dxc. So we can find out amount of work done. Frictional force is the same. So this is 50 times 5. We will get 250 joules. So this is the amount of work done. We need to find out extra work done. So extra work will be the difference between these two. We can say extra work done. Extra work done. So what is total work done from x to y and y to z? So we have 150 here, we have 200 here. So this is equal to 350 minus this work done from x to z. This is equal to 250. So in this case, we will get 100 joules. So this is the extra amount of work. So the answer for this question is A. Question 19 says the momentum of a car of mass m increases from P1 to P2. What is the increase in kinetic energy of the car? So first of all, we need to find out the relationship between kinetic energy and momentum. So we can start with momentum. Momentum is equal to mv. So from here we can say v is equal to p divided by m. And kinetic energy is equal to 1/2 mv squared. So we can plug in value of v. V is equal to p divided by m. So we have p divided by m. Square of this one. So we will get 1/2 m p squared divided by m squared. We can cancel this m with this. So we left behind with kinetic energy that is equal to p squared divided by 2m. So this is the main formula you need to answer this question. Now we need to find out the change in kinetic energy. So we can say kinetic energy 2 minus kinetic energy 1. Kinetic energy 2 will be equal to p2 squared divided by 2m. Kinetic energy 1 p1 squared divided by 2m. So in this case 2m we can take out. So we can write down 1/2. So here we have p2 squared minus p1 squared. We can also write down this one, P2 squared minus P1 squared divided by 2. So the answer for this question would be A. And this relationship is very important one. So this must be in your mind to answer questions quickly. Question 20 says a parachutist is falling at constant terminal velocity. Which statement is not correct? So first of all, we need to understand parachutist is falling at constant velocity. If any object is falling at constant velocity, where the decrease in potential energy will go. Constant velocity, first thing you need to understand, it means change in kinetic energy is equal to 0. Now the question is that where potential energy will go, because the potential energy is also decreasing. So the change in potential energy, delta GT, if potential energy is decreasing, it will be converted into thermal energy of air. It will increase the temperature of the air. So we can say thermal energy of the air, and it will give some kinetic energy to the air particles. So we can say kinetic energy of air particles. So it will also give, because when particles collide with the object, they will gain some kinetic energy. And also the decrease in potential energy, this will also become thermal energy of the object. So in this case, thermal energy of the parachutist. Due to friction, the body temperature of parachutist also increase. So we can say thermal energy of the parachutist. Thermal energy. So this is where GPE will go. So decrease in potential energy will be converted into thermal energy of the air, kinetic energy of air particles, and thermal energy of the parachutist. This question is very common question, so you need to be very clear. If object is falling at constant velocity, where decrease in kinetic energy, potential energy will go. Decrease in potential energy, that will be converted into thermal energy of air, thermal energy of the falling object, and kinetic energy of air particles. The question is asking which statement is not correct. Gravitational potential energy is converted into kinetic energy of air. This is correct. Converted into kinetic energy of the parachutist. No, parachutist kinetic energy remains constant. So this statement is incorrect, and this is the answer. Converted into thermal energy of the air. This is correct. Into thermal energy of the parachutist. This is also correct. So these points are very important points you need to understand to answer questions next time, not only to answer this question. Good morning, good afternoon, or good evening. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2025, Paper 1, Very 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics, and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 21 says, the student investigates a spring. The variation of the length of the spring with the force applied to the spring is shown in the figure. We need to find out what is the spring constant of the spring. So this question is pretty straightforward one. Simply we need to use Hooke's law. Means F is equal to K times delta X. So in this case, K will be equal to delta F divided by delta X, means the gradient of this curve. So we can take 2 points, we can take this 1 point, we can take this and other point. Now simply we can plug in values. So the maximum value of the force in this case is 2.4 and the minimum value is 0. So we can simply say this is 2.4 minus 0 divided by the change in length. So we have minimum value of length, we have the maximum, so this is the extension. That will be equal to 0.60 minus 0.20. So the answer in this case should be equal to 6.0 newtons per meter. So the answer for this question is D. Question 22 says the graph shows the variation with force of the extension of wire. The force is gradually increased to a maximum at Q and then gradually decreased to 0 at R. Which statement is correct? Now if you look at the given options, it is given to us along the line PQ, the wire obey Hooke's law. Along line PQ. This line is not a straight line, so it does not obey Hooke's law. Along the line RP, the spring constant is equal to extension of force. This is wrong. It has to be force over extension. So this option is also incorrect. So this is incorrect. The wire has elastic deformation at U. Yes, because the wire returned back to original length. It means it was elastically deformed at this point. So it wasn't deformed elastically. So the answer for this question should be C. The work done in stretching the wire to D is equal to force time extension. No, it has to be divided by 2. So this option is also incorrect. So the answer is C. Question 23 says a uniform metal wire of length capital L and diameter D has spin constant K. What is the Young modulus of the metal? So we need to understand how we can determine Young modulus of the metal. If we sketch a graph between stress, unit is newtons per meter square, and strain has no unit. It is the ratio between two same quantities. In the first part of the graph is a straight line. Until this point, stress and strain, they are directly proportional, and the gradient of this graph is equal to Young modulus. After this one, the shape actually can be this shape. It depends on the material. So shape will be depending on the material. And this point is also the limit of proportionality. And until this point, Hooke's law is also obeyed. So these are the points you need to understand to answer this question. So we can simply draw this dotted line. So until this point, Hooke's law is also obeyed because it's a straight line. So it's just a straight line. Hooke's law is obeyed. So simply we can say Young modulus in this case is equal to stress divided by strain. And stress is force over cross-sectional area of the metal. If the pipe is hollow like this, so you have to take cross-sectional area of the metal. In this area, how much is this cross-sectional? In this area, you have to take. And this is divided by delta L by L. So if we simplify this one, we can simply say this FL divided by A times delta L. So if you look at the given answers, in the answers we don't see the force and we don't see cross-sectional area. So we have to write down force and cross-sectional area in terms of the quantities in the answer. So the force, as this will obey Hooke's law, we can say F is equal to P times delta L, and A will be pi by 4 T squared diameter, because cross-sectional area of wire is circular. Now simply we can plug in these values. So we can say F, we can replace this one with A times delta L. So this is L divided by, we have pi by 4, and here we have D square, and this is multiplied by delta L. So now we need to just simplify. So delta L, we can cancel with delta L, and this 4 can write down, this will be 4 K L over pi D square. So this is the final answer. So there are some key points you need to understand. The first key point is you need to understand the point until stress and strain, they are directly proportional. You need to find the gradient of that point. That will be to Young modulus. And until that point, spring or wire, they will also obey Hooke's, and that's the main concept you need to understand. So this is also limit of proportionality, because until this point Hooke's law is obeyed. So the answer for this question should be D. So this is the answer. Question 24 says an aircraft produces a sound at a frequency of 30 Hertz. The speed of sound in air is 330 meters per second. The aircraft is directly in front of the stationary observer and travels in a straight line towards or away from the observer. The observer hears the sound from the aircraft at a frequency of 20 Hertz. What is the speed and direction of the aircraft? So if you look at this given information, so here we have frequency of the source, because this is the frequency of the sound produced by aircraft. So this is Fs, and this frequency, this is the frequency of the sound heard by observer. So this is F naught. So as in this case, F naught is lower than Fs. So it means source moving outward. So this is, we can conclude from given information. So we can say, in this case, source is moving. Now we need to find out the speed. So simply we can write a Doppler effect equation. F observed, this is equal to speed of the wave divided by speed of the wave plus, this is speed of the wave, plus speed of the source. Speed of the source multiplied by frequency of the source. So we need to find out Vs in this case. So we can write down F observed times Vw plus Vs. This is equal to Vw times Fs. So we need to find out Vs. So we can multiply this inside. So we can say F naught times sub W times F naught times Vs is equal to VW times Fs. This is VW, speed of the sound. So we need to find out Vs. So we can write out Vs, this will be equal to VW times Fs minus F naught times VW, and this will be divided by F naught. So we can take common in this case now. VW is common, so we can take out. So we have here Fs minus F naught, and this is divided by F naught. Now simply we need to plug in values and we can find the answer. So speed of the wave is given. So speed of the wave we have here, so this is 330, and source frequency we have minus observed frequency divided by observed frequency. So if we solve this one, we will get 165 meters per second. So away from observer 165, so the answer is C. So this is how you can approach Doppler effect problems. Question 25 says, which statement about longitudinal and transverse wave motion for a progressive wave is correct? Option A says all transverse and longitudinal waves require a medium for propagation. Transverse wave, all transverse waves, electromagnetic waves, they are also transverse waves, but they do not require medium for propagation. So it means this option is. Option B says all transverse waves travel at the same speed, but longitudinal waves can travel at different speeds. Same speed is incorrect because speed of the wave depends on the medium. So the same type of wave, it can have different speeds in different medium. So you need to understand speed of the wave speed, it depends on type of the wave and it depends on medium. So we can say type of wave. So option D is also not correct. Option C says in both transverse waves and longitudinal waves, a particle with zero displacement has a maximum speed. This option is correct. So if we draw a wave, so let's say y-axis is representing displacement and this is representing distance. So the wave will look like this. So this is the wave. So in this case, the particle at equilibrium at this point, this particle will have the maximum speed. It will have the maximum speed. So it will have Vx, and particle at the top, its speed will be equal to 0 because its direction is changing. So option C is correct. Option D says in a longitudinal wave, there is a net movement of particles in direction of travel of the wave, but there is no net movement of particles in a transverse wave. Particles, actually there is no net movement of particles in direction of travel. So what is transfer in direction of travel? That is energy. Particles only oscillate. If you look at this particle, this will be oscillating up and down, but this particle will not move with that wave in direction of propagation. So particles oscillate, they have no net movement. So particles don't travel with the wave. So what is transfer along the wave? That is energy. Waves do not transfer matter, they transfer energy. So the answer for this question should be C. So D is also correct. Good morning, good afternoon, or good evening. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from June 2025, Paper 1, Variant 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 26 says, the diagram shows a progressive transverse wave on a stress string at one instant in time. One point on the string is labeled X. Which point on the string is 270 degrees out of phase with X? So for this one, we need to understand one wave we can divide into 4 parts. So this is one complete wave. Or simply you can imagine this is one cycle. We can divide this one into 4 equal parts. So this is one part and this is second part, this one is third part, and this is the fourth part. And one cycle, we need to understand, one cycle is equal to 360 degrees, and the distance traveled by one wave in one time period is equal to 1 lambda. So simply we can say 360 degrees represent path difference equal to 1 lambda. And so from here we can say that 90 degrees means lambda by 4, and 270 degrees means 3 times lambda by 4. Now if you look at the given point, so between x and b the phase difference is 90 degrees. So we can say this phase difference is 90 degrees. And the phase difference between x and c, this is 180 degrees. Phase difference between x and d, this is one complete cycle. So this is equal to 360 degrees. So if you look at point A, the phase difference between point A and x, this is equal to 270 degrees. So the answer for this question has to be D. Question 27 says, which wavelength of electromagnetic radiation in free space could be green light? So for this question, simply you need to understand what is range of wavelength of green light. Wavelength of green light is between 500 to 570 nanometers. Now, if you look at the given options, if you look at C, this is 550 nanometers. So this is the possible answer. But you can also look at the other options. So this is 490 nanometers, so this is not possible answer, and this is 660 nanometers, this is also not possible answer, and this is 860 nanometers, so this is also not possible answer. This one is very close, this is very close. So if you look at the wavelength in a more precise way, wavelength is 495 to 570 nanometers. So this is more precise. But if you simply remember 500 to 570, you will be able to answer in the exams. So the answer for this question is C. Question 28 says, which group contains only waves that can be polarized? So we need to be very clear. Only transverse waves can be polarized. So only transverse waves can be polarized. So if you look at given option, this is a transverse wave, this is a transverse wave, but this is not transverse wave because sound waves are longitudinal waves. Visible light, this is transverse. Microwaves, transverse. Radio waves, transverse. So it means E is the answer. This is also not answer because this is not transverse wave, not transverse wave. Question 29 says, one wave have an amplitude of 2A, a second wave has an amplitude of A by 2. The waves are otherwise identical. The two waves travel in opposite directions and overlap. What is the ratio between maximum amplitude of combined wave and minimum amplitude of combined wave? So first of all, we need to understand what is the maximum amplitude. What is A max? A max when they interfere constructively, so it has to be 2A plus A by 2. So this is simply equal to 5A by 2. And when is amplitude minimum? Simply you need to subtract 2A minus A by 2. So in this case, we will get 3A by 2. We need to find the ratio. So what is the ratio between these two? So A max, this is 5A by 2, and this is divided by 3A by 2. So simply we can say this is 5A divided by 2 multiplied by 2 divided by 3A. So these two will be cancelled with this one, A cancelled with A. So the answer has to be equal to 5 by 3. So the answer is question 30 says light of wavelength 680 nanometers is incident normally on a diffraction grating with 450 lines per millimeter. What is the angle of diffraction of the second order maximum in the diffraction pattern that is burst? So we need to find out angle, and this is diffraction grating. So simply we have to use d sine of theta. This is equal to m times lambda. We have m that is equal to 2 because this is second order. Value of lambda is given to us. But we don't have value of t. If we have value of t, simply we can plug in and we can calculate value of angle. In order to find d, so I'll be writing here, d, it is given to us, we have 450 lines per millimeter. D is equal to 1 over. So this is N. So in this case, we have 450 lines per millimeter. So if you write down here, so you can say 450 lines per millimeter. So it means that we can say 1 millimeter divided by 450 lines. So this is 450 lines, we can say. And so 1 meter, we have to convert into meters. So 1 millimeter is 1 times 10 to minus 3 meters. And this is divided by 450. Now, if we simplify, we will get 2.22 times 10 to negative 6 meters. So this is the spacing between centers of two slits. So simply we can say this is slits separation between centers of two consecutive slits. Now we need to just plug in here. So we can say in this case sine of theta, this will be equal to m times lambda divided by d. So we can say theta, this will be equal to sine inverse of m is 2. And the lambda we have, that is 680 nanometers. So you have to be clear with this one. It is given in nanometers. Lambdas are very small, so you need to be clear. It is in nanometers. So don't just plug in 680. And divided by value of the d, we have that is 2.22 times 10 to minus 6. Now if we solve this one, we will get in this case 38 degrees. So this is the answer. So the answer for this one has to be, this is not answer has to be D. So D is the right answer. So this is the main point you need to understand. D is equal to 1 over number of lines per millimeter. So we can say 1 millimeter over 450, and then you can find the value of the D. Question 31 says a hollow tube is closed at one end and open at the other. A stationary sound wave of the lowest possible frequency, 820 Hz, is produced in the tube. The speed of sound in air is 330 meters per second. What is the length of the tube? So first of all, it is given to us, this is one end closed by. So simply we can draw, this is one end closed by. The second thing you need to understand is that it is given to us the lowest possible frequency. It means this is the fundamental frequency. Now this is one end closed pipe, so this end must be a node and here will be antinode. So simply we can draw the possible. So this is the stationary wave produced inside this. Now this is antinode. So this is antinode and this one is the node. So this is the length of the pipe. This is L of the pipe, and L in this case has to be equal to lambda by 4 because the distance between two consecutive node and antinode is lambda by 4. So we need to find out length of the pipe, means simply we need to find out lambda by 4. So now if we have value of the lambda, we can find out the length of the tube. So how we can find out lambda? So we have V given to us, we also have F. So lambda simply will be equal to V divided by F. So you have 330 meters per second we have, it is given to us, and the frequency we also. Now if we simply solve this, we'll get 0.402 meters. So what is the L? This is lambda by 4. So simply we can say this 0.402 divided by 4. So we will get 0.10 meters. And this is equal to 0.10 if we convert into centimeters. So we will get in this case our final answer, that will be 10 centimeters. So this is the final answer. Question 32 says which expression gives the definition of resistance? So we need to understand resistance is equal to delta V by delta V is the PD across component and I is the current. Then we can figure out what is the resistance. Now if you get a given option, so current divided by potential difference, no, this is not answer. Current divided multiplied by potential difference, this is also correct. Potential difference divided by current, yes, this is correct. Resistivity multiplied by length, this is also not answer. So the answer for this question is C. Simply you need to understand Ohm's law. Delta V is the potential difference across component I is current passing through the component, and this is the main takeaway. Question says the graph shows IV characteristics of an electrical component. What is the component? So simply we need to identify what is the component. If you look at this graph, in this direction, there is no current passing through the component. So it means current in this component can only flow in one direction. So this one has to be diode, because current in diode can only flow in one direction. So this is symbol for the diode, and if this side is connected with positive terminal of the battery, then this is connected with the negative, so current can flow, but opposite is not possible. So the answer for this question has to be D. Question 34 says the diagram shows 6 identical resistors connected in a circuit. In which branch of the circuit is the most power dissipated? It is given to us they are identical resistors, so we can say resistance of each resistor is equal to capital R. So we can assign letter R to each resistor. So this is R, and this is also R. We can redraw the circuit. So we can simply say, let's say this is point P. So this is point P. And here we can take, this is point Q, and here we can take, let's say this is point S, and here we can take, this is point R. Now simply between point P and Q we have two resistors, so we can replace them with one resistor. So the resistance of this one resistor has to be root R. And between Q and R we have one resistor, Q and R, so we can draw here. So between Q and R, so have one resistor, so simply we can write. This is just a wire, so it doesn't matter to just make this circuit simple. And between P and S we have one resistor, so this is P and S, we can draw here, this is one resistor. And between S and R we have two resistors connected in parallel. As these two, they are connected in parallel, so the total resistance of these two should be equal to R by 2. So we can draw one resistor here, and the resistance of this resistor is R by 2. So this is R. So this is also R. And power supply is connected here between P and R. So this is our power supply. Now this circuit, you can see, looks very simple. What is the total resistance of these two? We can replace them with another resistor. So resistance should be 3 times. So this is our point P. So this is point R. And resistance of these two, it has to be equal to 3R by 2. So we can draw here. So resistance of this is 3R by 2. And our power supply is connected. So this is our power supply. Now, as these two resistors, they are connected in parallel. So the PD across them is the same. PD is the same. So if PD is the same, and if one resistance is greater, let's say it's double, so the current should decrease. We can say I will be half if resistance is double. Now we can imagine, let's say current I is coming from the power supply. This current is I. And this current will be divided into two parts. One part will be double here. So this has to be equal to 2I by 3. And this current has to be I by 3. So you can figure out from here as well. So let me explain in a better way. Let's say V1, this is equal to V2. So we can also say, let's say this current is I2, and this current, let's say this is I1. So I1 times R1 should be equal to I2 times R2. Means this total resistance, I'm saying this is R1. This resistance I'm saying is this is R2. So from here we can see that the ratio between I1 over I2, this has to be equal to R2 divided by R1. As R2 is double, this is double, so you can write on here, this is 3R divided by 3R by 2. So what we will get? We will get, in this case, this is equal to 2. So it means that I1 should be equal to 2 times of I2. So it simply means that current passing through this one has to be double of current passing through this resistor. So that's the reason we have said this is 2I by 3 and this is I by 3. Means the current we have divided into 3 parts. 2 parts go through this lower branch, 1 part go through the upper branch. So this is I by 3. Now it means that current passing through this resistor, this has to be equal to 2I by 3 and current passing through this branch, you can label here, this branch has to be I by 3. So current passing through this resistor is double. How about current passing through these two resistors? So let me clear this one and write down how much current is passing through these two resistors. We can say R this time. Now 2I by 3 is coming. So they have the same resistance and the PD across them is also the same. So current passing through this one has to be equal to I by 3 and passing through this also has to be I by 3. Now you can see I by 3 current is passing through these two resistors, this resistor and these two resistors. But through this resistor, current passing is 2I by 3. So it means power dissipated in this resistor will be greater because P is equal to I square times R. Current is double, so the power will be 4 times. So we can say the power dissipated in this resistor, we can say TS. This has to be equal to 4 times of power dissipated in other resistors. So this is how you can answer this question. A little bit long one. I try to explain in detail so you can understand how to approach this type of problems next time. So the answer for this question should be SP. SP means this resistor. So current passing through this resistor is 2 times and power dissipated in this resistor will be 4. So this is that. Question 35 says the diagram shows a circuit containing a thermistor, a fixed resistor and a battery. The graph shows the IV characteristics of both components. The battery has an EMF of 12 volts and negligible internal resistance. What is the current in the fixed resistor? And this question is a very common one. So in other past papers, you will also see. So you need to understand how to answer this question based on the given graph. For this question, it is given to us, the EMF of the power supply is 12. So it means that the V plus VT, it has to be equal to 12. So now from the graph, for example, if you look at this point, so the PD at this point across these two components will be greater than 12. So this point is not a suitable one. So we need to look for another point. Now, if you look at this point, let's say here, and if we draw the line, so we can draw the line here. Now we can also draw the lines from these curves down. So we can draw this here. And from this thermistor curve, we can also draw the line. So the line here at this point, you can draw. Now, if you look at these two, we can see this PD is 5 and this PD is 7. So it means 5 plus 7. This is equal to 12. So we have 5 plus 7, that is 12. Now, current has to be the same because they are connected in series. So what is the value of the current here? Now simply you need to read. Because this is 0.2, so this will be 0.4, 0.8, 0.28. This is 0.24. This will be 0.28. This will be 0.32. This will be 0.36. So 0.36. So the answer for this question has to be. And this is how you need to answer this type of problems. Question 36 says two resistors of resistance R1 and R2 are connected in parallel. What is the combined resistance between X and Y? So very simple question. So let me explain a little bit in detail. So we can say that 1 over R total. This has to be equal to 1 over R1 plus 1 over R2. So first of all, we can take LCM. So this will be 1 times R. So if you divide R1, R2 by R1, we get this R. And here we will get 1. So this is 1 over R total. So the R total, if you just flip this one, R total should be equal to R1 times R2 divided by R1 plus R. So the answer for this question should be B. So this is the answer. Question 37 says a cell is connected in series with an ammeter and a variable resistor. A voltmeter is used to measure the PD across the variable resistor. The resistance of the variable resistor is varied and the PD and the current are recorded. The graph shows the variation with current of the PD across across the variable resistor. What is the internal resistance of the cell? And so it is given to us. We have a power supply, and this power supply also has internal resistance. So we can say this is internal resistance. Then it is given to us there is an ammeter in the circuit, and we have variable resistor. So this is representing variable resistor. It is also given to us we have voltmeter connected across this variable resistor. We can say EMF of this one is E and this is small r. We can say the resistance of this one at any given time is capital R. So we need to find out what is value of internal resistance. We can also draw here. So this is our cell. So this is our complete cell. So internal resistance is inside here. So now if we write down the equation for this one, EMF has to be equal to I times R plus the PD across this one field. So if we get the graph between V and I, so we can rearrange this one. So we can say this will be minus I times R plus EMF. Now if we compare this one with straight line equation, so this is Y is equal to mx plus C. So the internal resistance should be equal to the gradient. So we have, so this has to be the gradient. So we can say the gradient has to be equal to, in this case, minus R. We can say R has to be negative times the gradient, negative of the gradient. So this is the main idea. Now simply what we need to do is we need to find out the gradient. To find the gradient, we can take two easy points. We can take this point, we can take this point, and we can write down the coordinates of these points. So this is 1.6, 0, and this is 0.2, this is given in milliamps. So this has to be equal to 0.70. Now we can find out the gradient. So the gradient simply will be equal to, we can say the gradient that will be equal to 0.2 minus 1.6 divided by 0.7 minus 0. And now if we solve this one, we will get this is minus 20. But we need to understand that gradient is equal to minus R. So we can say this is minus R. So minus minus cancel. So R is equal to 20 ohms. R is equal to 20 ohms. So the answer for this question should be C. Question 38 says, which list contains only fundamental particles? So fundamental particles are quarks and leptons. Now if you look at the given options, antineutrino, this is fundamental. Baryon, this is not fundamental. Neutron is not fundamental. Electron is fundamental. So A is not answer. Mesons, not fundamental. Electrons, fundamental. Neutrinos, fundamentals. Protons, not fundamentals. Positron is fundamental because this is antiparticle of electron. Quarks are fundamental. Hadrons are not fundamental. Protons are not fundamentals. Quarks are fundamental, positron fundamental, neutrinos fundamentals, leptons fundamentals. So the answer for this question is D. Question 39 says, which statement explains why alpha particles have discrete energies but beta particles have continuous range of energy? This question is very common type of question. You will see in long questions, meaning paper 2, and also you will see this one in paper 1. So let's try to understand first of all kind of decay. So we have alpha decay. In alpha decay, alpha particle will be emitted and there will be daughter product depending on the reaction. So this is daughter product. In each alpha decay, the energy of emitted alpha particle is fixed and daughter product, this is also fixed. So that's the reason they have discrete energies depending on reaction. But in beta decay, beta particle will be emitted. It can be beta plus or beta minus depending on the decay. And also there will be neutrino or antineutrino emitted depending on the reaction. And also there will be daughter product. So there will be daughter product. But energy of these neutrinos is variable. So this energy is variable. So the energy of beta also has to be variable. So that's the reason beta particle is emitted with continuous range of energies. But alpha has discrete energies. Because the energy is shared between these two. They share energy. and energy is variable. So that's the reason there is continuous range of energies. Now, if you look at the given options, it is given to us beta particles have much smaller mass. This is not the reason. Mass is not the reason. Only alpha particles experience repulsive forces from the nucleus. This is also not the reason. Only beta particles are emitted with an other cloud. This is the reason. And some energy is transferred to the other. Yes. So the answer for this one has to be C. So C is the answer. Question 40 says a hadron consists of antiquarks that are all identical. What is a possible value in terms of the elementary charge E for the charge on the hadron? So we need to understand hadrons are classified as baryons and mesons, but mesons must consist of quark and antiquark. So it is baryon. So it means it consists of three particles. So we can say three particles means three quarks. Those three quarks can be all quarks or can be antiquarks or combination of that. So three particles. So we need to consider antiquarks. So first of all, we can take, for example, up quark. The charge on up quark is plus 2 by 3e. And we have down quark. The charge on this one is minus 1 by 3e. And we have the top quark. The charge on top quark is also the same. So we can say the charge on top quark is the same and the charge on charm quark is also the same. So down quark, and we have the bottom quark, and we have the strange quark. Charge on them is equal to this. So the for example, anti-up quark, the charge on anti-up quark would be minus 2 by 3e. And the charge on anti-down quark. So I'm just taking one quark. So down quark, charge on this one will be plus 1 over 3e. Now simply we need to multiply them by 3 so we can figure out which charge is possible, which is not possible. So the first thing you can see, this is not possible. So this option is not possible. This option is also not possible. So the answer has to be B. Our answer has to be C. C is also not possible because if we multiply minus 2 by 3e with 3, what we will get? This will be minus 2e. So this option is also not possible. Now we can look at this one. So we have 1 by 3e. If we multiply by 3, because 3 quarks we have to consider because we are talking about baryon. So this will be equal to 1e. So the answer for this question is B. So this is how you need to answer. And that's all for this video. I hope you have better understanding of this question and also the whole paper. If these videos are helping you, please like and subscribe. And also if you have any questions, you can leave your questions in the comments and I will try to answer as soon as possible. And if you're looking for more resources, you can also join on Patreon. You will see a lot of resources. And if you need individual help, you can also email. See you in next video.